We are going to find the slope of a line using this intuitive idea that slopes should measure the amount of change in the y direction when we move 1 unit right in the x direction. So if I move 1 unit over, what is the change vertically? We expect that if we do have a line moving through the origin, that can represent a proportional relationship like a unit rate. For our first example, let's just think of this case moving through the origin. I'm going to start with a point P right there at 0, 0. If I were to move 1 unit to the right, I would now be at a point Q, which has coordinates 1, 0. So it's still on the x-axis. By drawing a vertical line through the point Q, I can now identify where on the line I care about, where the point is that is 1 unit to the right. And that's this point here that I have labeled R. So step 1, we fixed a point. Step 2, we marked a point Q that was 1 unit to the right, still level with P. Step 3, we made a vertical line through it so that we could see, and some of this you can do just by following the grid. Step 4, we identify that point R. That is exactly 1 unit to the right. Now the length of the segment from R to Q, this is that change in Y when we move 1 unit right on the line. Therefore, the slope will be equal to that value. We call this step 5. For increasing lines, the slope will just be the increase in the y coordinates. In my example picture that I have used here, right below on the left, notice what that makes my slope. If I measure the length of RQ, this length, the length of RQ is 16, so the slope of the line is 16. On this graph, this graph of this line, as we move 1 unit to the right, we increase our height by 16. Next, let's consider what would happen if our line had not passed through the origin. Well, in that case, I have to add in a small step. I have an example of a line here. You'll notice we can't even see the vertical axis. It's way over here. And I have a point P that I've marked on the line, first step. But now, since I'm not on the x-axis, I'm going to put in a horizontal line through P. So I'm going to put that line in, and I'm naming that line L1. Next, I'm going to mark a point 1 unit to the right on this line L1. That way it's exactly level with P at the same height as P, same y coordinate, and it will be 1 unit to the right. So that I can build that perpendicular vertical line through Q to find my point on the line I care about. So I've made my point 1 unit to the right, and then I draw a vertical line through Q again. The point where my red line L intersects with my green vertical line through the point 1 unit to the right is R, that's step 4, and the y coordinate of R, its increase is what we are caring about. We want to know if I've moved 1 unit this way, how high up have I gone? So the length of my RQ here is going to be my slope once again. To calculate it, if I have a nice grid that I can read off the graph, this is not a difficult thing to do at all. I can just count the little boxes. Now you want to see here, this is a major grid line here. This is another major grid line. So this distance was 1. And it looks like the subdistances are measuring 2/10 each because we have 1, 2, 3, 4, 5 of them in between. So the distance from Q to R based on that measurement in this example is 1 4/10. So in this case, when we moved 1 unit to the right, the line had an increase in y coordinates of 1 and 4/10. So we would call the slope of this particular line 1 and 4/10. Here we have our third example. I am going to choose to assign my point P to be the point right here. What are the coordinates of that point? Type them in the chat. We might need them later. I'm going to put in my horizontal line through P. That's my L1. And then I'm going to mark a point 1 unit to the right of P. Here, each box represents 1 unit. So Q is the point right there. Next, I'm going to draw that vertical line through Q. This vertical line. And I find the place where that vertical line intersects the red line I started with, my line. That is this point here, R. So the length of RQ, the length of this segment, will be my slope. It's how much higher up we've traveled when we move 1 unit to the right. And it looks like R is at about 1 and 5/10, 1 and 1/2 units above Q, but it's hard to tell exactly. So I'm going to use a strategy in order to find the value exactly of the slope here. I'm going to use similar triangles. The way I'm going to do this is I drew this orange triangle that you can see here on the graph, highlighting the point P as one vertex of that triangle, and then the other 2 vertices were the point where the horizontal line through P hit the y-axis. So notice this is the point 0, -1, and also the point where the line L itself hit the y-axis. This point up here, which has coordinates 0, 2. I'm going to go ahead and name those 2 points A and B, and let's draw a triangle. It's a right triangle because it is the intersection of a horizontal line and a vertical line that form that part there. And here we go. We have RQ, that's the length we want. We have our point P, we have B, and we have A. Because the length from B to A that moves right along the axis, that's a vertical number line, I can count or take the distance from -1, the y-coordinate at B, to 2, the y-coordinate at A, and I get that the length of AB is 3. I also know that the distance from P to B should be 2 units because the coordinates of the point P were -2, 2, -1, and therefore, since B was on the y-axis and B had x-coordinate 0, this full distance PB was 2. Whereas I selected point Q and point R because they were 1 unit in the x direction away from P. So I get the following 2 ratios. Because they're both bases of similar triangles, I have that PQ's length divided by PB's length should be the same ratio as the length of RQ divided by the length of AB. Those are the heights of the 2 triangles. Now I know the length of PQ is 1. I know the length of PB is 2. And I can see that the length of AB is 3. So I now have a proportion where I only have 1 unknown. And I can use cross multiplying to get my answer. So I get 2 times RQ must equal 3 times 1, and thus the length of RQ is 3 divided by 2. And that tells me that the slope of this line is 1.5 or 1 and 5/10, which is equivalent to the fraction 3/2. So I'll write that as our final step. We will now work together on finding the slopes of lines where they are declining from left to right.